Okay, so what we will do today is we will design a differential amplifier. Uh, so first open the terminal and go for CSH. Then source/home/install/cshrc. Then invoke the Virtuoso. So this may take some time. Okay, so the Virtuoso portal is opened. So now file, new library. Okay, so what we will do today is we will do a differential amplifier. So I am making the library name as diffamp lab. Okay, then attach to an existing technology library. Then click OK. Okay, so we will attach GPDK 45 nanometer file today and click OK. Okay, so GPDK 45 is successfully attached. So next file, new, then open cell view. Okay, so in cell view, so our library name is diffamp lab. Okay, and give a cell name. It will be diffamp. Okay, then it is schematics. Then click OK. Okay, so this is the layout editor. So what we will do is we will draw the circuit diagram. Okay, so for selecting the instance, type I. Okay, so in library, so we are actually using GPDK 45 nanometer file. So select GPDK 45 nanometer and inside it, so we need to take the transistors. So differential amplifier, as you know, we have two NMOS transistors and two PMOS transistors as the load. So first I will take the PMOS load. So select PMOS 1 volt. I am not tweaking any parameters. So hide. Okay, so place it somewhere here. Then again type on I. So again I need this thing PMOS, but I need to fold it. So use the option sideways. Okay, then again click hide and place it somewhere here. Okay, so the PMOS is now over. Now we can go for NMOS. So NMOS again under GPDK 45 library, take NMOS 1 volt. Okay, all the parameters are here. So I have my NMOS. So one will be here and again type I, then use sideways, and the next thing will be here. Okay, so I have my two PMOS and two NMOS. So now we need to give the biasing. So for giving the biasing, again I need NMOS. So what one NMOS I will place it here, and other NMOS I want to rotate it. So we're moving the selection. Again NMOS. Okay, so I will place somewhere here. Okay, so all the transistors are there. Now we need pins. Okay, so for taking pins, type on P. So first I need VDD, supply voltage, sorry, supply voltage VDD, direction is input. Okay, so I need my VDD here. So I'm rotating it. First to rotate, type R. Okay, so this is my VDD. Next I need VSS. So again type P. So VSS, it is again input. Again rotate it, place somewhere here. Okay, so VDD and VSS is there. So now we need differential inputs, V1 and V2. So again P, direction is input, V1. So I'll place my V1 here. And now V2, rotate it. So this will be my V2. Now, one more thing is that we need IDC, the bias current. So for that, again P, IDC. Okay, rotate it because this IDC should come on to the drain of this NMOS transistor. So I'm keeping IDC here. Then finally, output. So it is V out, direction is output. Output should come from the drain of these two transistors. So I'm keeping it here. Okay. So now the components are all here. So now we have to wire it. So type W and give the wiring. So source of PMOS and PMOS is connected to VDD. Then drain connected to this drain. Here also drain is connected to the drain of NMOS transistor. And we have the body terminal here. So connect the body terminal to source or this connection. Also this transistor, connect it here. Okay. And gate is connected together. And as we have learned, the gate of this PMOS should go to the drain of this PMOS. Okay. Yeah. So the load part is over. So now we can come to this thing, NMOS transistor. So V1 input is given to gate of first transistor, and also V2 is given to the second transistor. The sources are shorted. Sources are shorted together, and it is connected to this drain because bias current should be given to this transistor. So for giving bias current, what I will do is I will take another transistor and I will connect both these transistor, gate of the both these transistor, and I will give an IDC to the drain of this transistor. Okay, so there will be a this transistor will remain in saturation, and so a current will flow through this transistor. Okay, yeah, so sources of these two transistors should be connected together. Okay, and VSS connected to here. And we have the body terminal of this NMOS transistor that should be connected to the source. Okay. So this is connected. Again, this is connected. The body terminal of these two NMOS transistors are connected together, and this common point is I'm giving to VSS. Okay, so I hope the connections are on as V out. So we have to give the V out to the drain of this transistors. Okay, so now it is okay. So I will check and save. Okay, so there are no errors. Okay, fine. Okay, so since I have completed the circuit, what now I will do is I will create a symbol. So for creating a symbol, create cell view from cell view. Define lab, okay. Click on OK. Okay, so these are my pins. So left pins are IDC V1, V2. What I will do is I will make the top pin as VDD and the bottom pin as VSS. I will delete it from here. Sorry. Okay, so click on OK. Yeah, so this is my symbol. IDC V1, V2, VDD, VSS, V out. Okay, all fine. I will check and save. Okay, no problem. And I can close it. Okay, so now what I will do is I will again open the Virtuoso and file new cell view. Okay, so the library name is here. So now what I'm doing is I'm going to create a test bench. Okay, so diffam underscore test. Click on OK. Okay, so the new schematic editor is opened. So I will create a test bench here. So for creating test bench, I should now take the created symbol. So for taking the created symbol, take the library diffam lab, and yeah, so this is our symbol diffam. Hide it. Okay, so I have my symbol. Created symbol is here. Okay, so now I need to give the sources and biasing. Okay, so first we will give VDD and VSS. So type I. Uh, the library is analog lib and search for VDC. Yeah, so this is VDC. So DC voltage say I'm giving 2.5 volt. Okay, so I will place it somewhere here. Okay, so again type I. Again we need VDC for VSS. So DC voltage say something minus 1.1. Okay, minus 1.1 volt. I am placing it near VSS. Okay, so VDD and VSS are there. Now I need to give IDC, V1 and V2. Okay, so for IDC, search for IDC. Okay, so this is IDC and DC current, say I'm giving 1 U, which means it is 1 microampere. Okay, so hide. Okay, so maybe I have my IDC. So I'm keeping my sorry for that. Yeah, so I'm keeping my IDC somewhere here. Okay. So IDC is there. Now again type I. So now we need V1 and V2. Okay. So V1 and V2. Type V sign. Okay. So V sign. I'm not giving any DC voltage. The magnitude say it is 1 volt and amplitude say it is 5 millivolt and frequency say it is 1 kilohertz. Okay. So keep it somewhere here. And so V1 I am giving a 5 millivolt peak to peak sine wave. So V2 I will give a 0 volt, which means I will ground it. Okay. So I take ground. This is ground. So 1 for V2, 1 for this V sign, 1 for IDC, 1 for this VDC, and this VDC. Okay. Finally, we need a pin for V out. So type pi P and VO. Direction is output. So we'll place it here. Now we need to give the connections. For that, type W. Is connected here. VSS, VSS to ground. Then V2, V2 to ground. V1 to V sign. The ground goes here. IDC to IDC. Ground of IDC goes here. VDC. Ground of VDC. Okay, so the connections are over. I will check and save. No error. All fine. Okay, so now I will go on to simulate it. So for simulating, launch ADEL. Okay, so first thing we have to check is setup model libraries. So I am doing a 45 nanometer PDK. So 45 nanometer is selected. Unselect every other thing. And click OK. Then come to the analysis. Right click, edit. So what we will do is we will do a transient and an AC analysis. So first transient analysis, the stop time, let it be 5 milli. Accuracy is moderate. Apply it. Then AC frequency is okay. So frequency sweeping starts from say 100 hertz to say 150 megahertz. And sweep type is logarithmic. Points per decade. Let it be 20 dB. Leave rest all thing. Apply it and click OK. Okay, so to the two analyses are added here. Now the outputs, again come to the output section, right click, edit from design. So we need to get V1, V2. V2 is anyways ground, but no problem. We will select V2 also and output V0. Okay. Take set outputs. Yeah, net to ground V0. Okay. Click on OK. Mm, take ADL. Yeah, 3 portions are added. No problem. So save it. Save it and click on netlist and run. Okay. So we have the transient and AC analysis. So split it. Okay. Split it. Then select the card. Okay. Yeah, so this is our V0 and this is our V. Okay, so the peak to peak input voltage is 5 volt here, 5 volt, minus 5 volt here. And the peak to peak voltage for the output is somewhere around 2.082 volt here and 1.9 volt here. Okay. Then if you can take the AC analysis, you can see that the output is here. The gain is somewhere around 17.85 or something. So the gain is somewhere around 17.85. Okay, so this is a good differential amplifier. Okay, so you can find out the exact gain and uh, the frequency, cutoff frequency through the proper analysis. Yeah, so I will stop it here.